Okay, so thank you. Good morning. Thank you for coming to this talk about Docker and Grails. Let me please get now. So, as I said, thank you for coming to this talk about Docker and Grails. Before I start, I want to make a small disclaimer. This is not going to be a Docker session, or not. I'm not going to explain everything about Docker. But I'm going to explain only some things to understand the concepts. And as the same thing, I'm not going to explain everything about Grails. I assume that you know Grails, at least a little bit. But don't worry, because the examples are pretty simple. So what I'm going to talk about today is the problems that we have now developing applications with our traditional approach, and how we can solve that problems using Docker, and in this case with a Grails application. Before I start, let me introduce myself very quickly. I'm Iván López, on Twitter. I work at Kaleidos as a Groovy and Grails developer. I've been using Groovy for the last 7 years. We are a technological company based here in Madrid. I'm the coordinator of the Madrid Groovy user group, our local Groovy group here in Madrid. You are all invited to come sometime or even give a talk. I'm one of the guys behind this conference. Because, you know, if you don't have enough stress preparing a conference, you also need extra stress giving a talk. And I'm a regular speaker in some conferences. So let's start. Every year, we build applications that are more complex, have more requirements. We need to integrate with different third parties. And we also want to build that applications fast and deploy that application fast. And on the other hand, we have problems because our traditional approach is not that fast and cannot solve that problems. So I'm pretty sure that most of you have heard or even said, it works on my machine. And the thing is, you finish something, you push the code, and then a colleague says, okay, it doesn't work. And you say, oh, that's strange because it works on my machine. That's not good. So the thing is that it's fine if it works on your machine, but it also needs work on your colleague's laptop and on CI and at the end on production. That's the goal, right? You develop something to be used on production. And at some point, you are so tired of hearing it works on my machine that you think something like this. Say it again, please. I'm going to kill you. Because it's a real problem. When something only works on development or on one laptop development, but not in production, it's bad. We have another problem with environment. For example, in my company, we can choose whatever operating system we want. So I use Linux Mint. We all use Linux. I use Linux Mint. Most of my colleagues use Arch. Some of them use Ubuntu, Debian, even Fedora, or even SUSE. They're crazy. And the problem is that we all can install the same software, but we cannot control the exact version because Arch repos are always living in the future, and Ubuntu are most on the past. So we use Postgres, but not the exact same version. So think about it. You need Java 8 for your new Grails application. Okay, which update? The last one? Three updates before? It's not that simple. And the same happens, as I said, with Postgres, all your standard dependencies, Redis, Rabbit, Mongo, even something more complex like, for example, OpenCV, Nginx, or FFmpeg. So it's complicated to have the same environment for all the development team, and also for production. So I don't know if you remember, but some time ago, I think a year or something like that, there was a problem with the Grails Spring Loaded agent that it only worked until Java 1.8 update 31. If you upgrade it to the next update of Java 8, which was 40, it didn't work. It was a long time ago. Now it's working. You can use the latest Java 8 version. But the thing is that 2 weeks ago, I discovered that one of my colleagues was still using that old Java version, that update 31, because he thought that Grails didn't work with new Java 8. So he didn't update the version of the Java 8. So we are using Java 8, but not the same exact update, and maybe sometimes this is a problem. So let's focus, for example, only on this. This is something like this is most my current project. So only even with this small stack, Java 8, Postgres, Rabbit, and Nginx, and only those two distributions on Linux, we all, the development team, are using different versions. So the only thing that we can control are the Grails version and the Gradle version, because we use the wrapper, which is great, but the rest of our dependencies or the elements of our architecture are not the versions that we want. We also have another problem, which is production and development. So most of you know this thing, at least the Spanish people know about this thing, this picture. And as I said, this is development, it's not production. It should be pretty much the same, and the same happened with the CI environment, Q&A, pre-production. So for example, we like to use Debian stable on production, which now is Debian 8. But as you have seen in my previous slide, none of my colleagues on my actual project use Debian for development. So it's a problem. And another problem is, think about it. What happens when a new member joins your team? How much time does this person need to spend to configure the whole development environment to be productive? And it can be even worse if that person, for example, uses Windows. So it's a problem. So at the end, you can probably end with something not that bad, but pretty much the same. It can be a chaos. So I think that this guy probably is thinking something like this. But I know for sure that he's also thinking if there was another way. And the thing is, there is another way. It's called Docker. So now I'm going to talk about a little bit about Docker. So we are going to see some pretty simple example. It's going to be a very fast 101, because I need to be sure that all of us are on the same page for the next for how to use Docker with Grails application. So if you know about Docker, this is going to be a little boring for you, but it's going to be fast. So with Docker, we have this portable runtime for application. So we can put this container, which is something like a box, and we can put that box wherever we want. And every container, every box is isolated from the rest, and we can control exactly what we put on that box. So we are going to eliminate these concerns about compatibility, about the different versions. And at the end, Docker is something like a virtual machine, but without all the overhead of a new virtual machine. It's a lightweight than a virtual machine. So this is for a virtual machine. You have your server, the host operating system, and the hypervisor. And on top of that, you have your virtual machine. So a new guest OS, some binaries, some libraries, and on top of that, your application. And if you want to deploy a new version of that application, you can create another virtual machine, just exactly as the other one. And you can also create another different virtual machine with different binaries and libraries and another application. So all this layer, it's a virtual machine. On the other hand, with Docker, we have a server, we have the host OS, and we have this here, the binaries and libraries, and the application is on top of that. And we can share the same binaries and libraries with different instances of the applications. And if we have another binaries and libraries, we can share it. So Docker is here, and basically these are the containers. So the result is that we have this significantly faster deployment, development, much less overhead. So now let's see how we can use Docker. So you need to install Docker on your machine. And if you execute this command, docker run --rm ubuntu echo hello Greach, what Docker is going to do is going to pull from the Docker Hub repository the Ubuntu image, if you don't have installed on your machine. It's going to create a container from that image, and it's going to execute echo hello Greach inside that container. And at the end, because of this --rm, it's going to delete this container. So the first thing here is that you have images and containers. The images are something like, for example, what you develop with Groovy, with Java, the class, and the containers are the instance. You create different containers from the same image. So imagine that you want to test Java 9 on your laptop, but you don't want to install Java 9 because you are using Java 8, the different version. So you can do something like this: Docker run Java 9 and Java DOS version, and it will the same. Download the Java 9, and here we have the version of NJDK, the last build from January. So you can start playing now today with Java 9, but you don't want to write this very long line. So you can do something like this. You can create an alias, Java, and now if you execute Java DOS version, it will print exactly the same. So it's a nice way to do or to use Docker containers for some testing or for trying new things. We can also create our own image. So we need to define a Docker file. And here we are saying, from that image, Nginx, and this version, it's the latest stable version, you are going to download this image, and you want to copy your local index file to that path. This path is the default for Nginx. You want to expose the 80 port because 80 is the default port for a web server. And at the end, you want to execute this command to start Nginx. And this index HTML file is just that simple, hello Greach. So now with these two files, you can create an image with them. Docker build, -t, name of the image, Greach, and dot, because these files are on the same directory. And it will download everything if you don't have installed locally. And the output will be something like this. Here we have all the steps and all the intermediate containers. And at the end, successfully built. So now you have created this image, and you can run it. Docker run. We are mapping our local port 1234 to the port 80 inside the container. So now we can connect to localhost 1234, and we have our web server. Okay, so let's talk now about Grails and Docker, how we can use all of these advantages of Docker while we are developing our Grails applications. So as I said before, imagine what happens if tomorrow a new developer joins your team. How much time does this person needs to spend to configure the whole environment to be productive? And this is a question. 5 minutes? Someone? Yeah, one? Half an hour? 2 hours? A day? A week? So it's not that simple. So our goal is something like this. We want that our new team member only need to install Docker, clone the repository, execute a script, and profit. Start being productive from the very beginning. So let's do this. So this, I have created a very basic application, a Grails application, and I'm going to show you how you can do all that stuff. So I have a producer that will create some messages. I have a consumer that will receive those messages, use it RabbitMQ, and the consumer will reverse this string and store on a Postgres database. So it's very simple, but we have 4 different components, four moving parts that we need to configure. We need to be sure that they all talk each other. So it's pretty simple, but it's not that simple. It's not just a scaffolding app. And with the traditional approach, as I said, the only thing that we can control is the Grails version, 3.1.4, the latest Grails version. But with this Docker approach, we can also control the environment, the final environment. We are going to use Debian 8 because it's the environment that we use in production, the exactly update that we want from Java. RabbitMQ, we want that version, and the same for Postgres. So now the whole team, the whole development team, it's going to use all this stack, the same for all of them. So no more, it works on my machine. Well, probably he can say, it works on my Docker. So I'm going we have 2 different options. Well, maybe we have more, but I'm going to show you 2 different approaches. The first one is the easy way, which I call one image to rule them all. And with this approach, what we're going to do is that everything, all the dependencies, all the application, everything is going to be run on the same container. And if you know a little bit about Docker, so here I'm going to start more than one process in the same container, which is something like, whoa, you shouldn't be doing that. So if you know about Docker, is one container, one process. But I don't care. This is for development, and it's good, and I'm going to explain why it's good. So this approach is very simple, very easy to maintain, but it's only for development. With this approach, we cannot put that on production, or we shouldn't, because it's for development. And the other option is this flexible way, which we are going to see how we can orchestrate all these containers. We are going to be how we can do more flexible things. So here we have each application, each component on a different container. So now we have one container, one application. It's more complicated to maintain. The example is going to be very simple, very easy, but if your application or your architecture is more complex, you need to do more things, but it's more flexible. You can use it it's ready for other environments, so you can use on CI, on pre-production, or on production if you want. So, as I said, I have here this producer and consumer Grails application. Let's start presentation mode. So, the first thing I want to show you, it's, as I said, is the latest Grails version, 3.1.4. So the producer, the only thing I have added here, it's this dependency, RabbitMQ, this Grails plugin. And I also need to, application Groovy. And here I'm using this to configure the queues. So the plugin will look for this file and create, it's going to create a queue with this name, reverse. And that's all from the producer. So the only thing is I have created a controller, pretty simple. I'm going to delete this. So if you just hit this controller, it will send this hello world, this default message, and if you pass another message, it will just send. Here I'm using this Rabbit template that this plugin provides. So I only need to do just execute, convert, and send on that bin. And that's all from the producer. So I forgot to say, don't worry about the code. I'm going to push to GitHub, and I'm going to tweet about it. So you will have all the code available to play after the talk. So this is the producer, and the consumer is pretty much the same. I'm using RabbitMQ, the same plugin, and I also need to use Postgres to store data on the database. The configuration file for the queue, it's exactly the same. And here, sorry, I have this service, which will receive all the messages sent to this reverse queue, which is the queue that I have defined. And for every message, I'm only going to print the message. And here I'm going to reverse the string and save this message. This message is just a very simple domain class. So that's all. And what I'm going to do now, I'm not going to show you the application running on my machine. So I have here this consumer and producer are the applications, and I have here this Docker directory. And I have two different directories, one for every demo. So let's go with the first one. And remember, as I said, I'm the new guy on the team, so I have cloned the repo, and I only want to execute one script to start being productive. So is this script, this build image, what I'm going to show you here, that will just create this. This is the name of the image it's going to create, reverse app/deb. And if I can show you the Docker file. So I'm not going to explain everything in detail, only the blocks, because you will have this available. So I'm using this version, OpenJDK, and that exactly update. This image is based on Debian, so I can use apt-get to get packages and install whatever I want. So I configure the locale. I'm going to add a new user, which is, the name is user. This is the user that I'm going to use for development. I want to use, I need RabbitMQ, so I add the dependency, and here basically I'm installing everything, some development themes, and Rabbit and Postgres. After that, I configure the plugin to enable the management plugin, and I configure the default user to be able to connect to the admin interface. I also install SDK-man, because this is going to be an image for developer, for a development environment, so you want to use SDK to manage all your Grails, Groovy, Gradle, all the different versions. And here I start the database, and I'm creating this reverse app user for the database and the database itself. I expose both ports. The first one is for Grails. The second one is for the RabbitMQ admin web page, and copy some custom files. So basically, this is the Docker image. So I can now run this, and it has finished that fast because I have all cache on local. But with a good internet connection, it takes something like 1 minute, maybe 2. So it's fast. So now I can show you Docker images. You can see here, it was built two days ago. So now I have created my development image. So I can go here, and with this start dep, I'm going to start a container from that image. So I'm going to show you this development. The important part is here, Docker run, and the name of the image. I'm mapping the ports because I want to be able to connect to the Grails application from my local machine, from my browser, and the same to the Grails, to the RabbitMQ admin plugin. Here with this, I'm mounting a volume, which here it's my current directory. I'm mounting my current directory inside this directory on the container. Basically, because I want to share the code between my local machine and the container. And here, this is a function. So it's Bash. It's not very simple. In Groovy, you can do this with one line, with that .join. And basically, that's the same. I have defined this here. So I want to share my local Maven, Gradle, Grails, and SDK directories from my local machine to the container. Because if I don't do that, every time I start a new container and execute Gradle w run app, it will download the wrapper and the whole dependencies over and over again. So if I share my local directory, it will download only the first one. It will be stored on my local machine. And the next time I start a container, all the dependencies will be there, just as if you are developing on your laptop. And this part is just to be able to start graphical applications. So I'm basically sharing my X11 socket from my local machine to the Docker. So now I can run the script, start dep, and I'm going to pass this tmux parameter. It's running. It takes a little bit because I don't have internet connection. I don't need it. And it's waiting because as I don't have internet connection, the interfaces are not very good. But if you have connection, you run the command and you have the prompt just like this. So now I'm inside of the container. You can see that this is the name of the user that I created. This is the name of this machine. And as I said, the first thing I need is I need to start my dependencies because I need Postgres and Docker for development. So let's run the script. So now I have running Postgres and Docker. Yep, inside the container. So 2 processes are running now. I don't care. I need it. They are there, and it's perfect. It's fine. And inside this directory, I have the same structure. So producer, consumer, and Docker. So now what I can do, it's something like this. This is the Grails application, so I can run Gradle w boot run. I'm going to start the Grails. No, sorry, not this one. The producer. I can start the application inside the container. And as all the dependencies are there, it's fine. If not, the first time you start the container, it will download the Gradle wrapper, all the dependencies, and that's all. OK, it's up and running, localhost 8080, development. So let's connect to this Docker. So localhost 8080. OK, this is my Grails application, 321, the version that I choose for Java 8, development environment, some artifacts, and some plugins. And you can see here RabbitMQ. And you have here this controller. And this is the default message, hello world. I can create another one. So hello Greach, and that's fine. So now, as I only have the producer running, all the messages are stored on RabbitMQ. So I can connect to the RabbitMQ admin. And here on the queues, you have the reverse queue, because my application or the Grails plugin will create or has created this queue during the startup. And as you can see, there are 2 messages ready, and we can see those messages. So get messages. The first one, hello world. The second one, hello Greach. And now I can send another one. This is awesome. Third message, sorry. Now we have 3 messages, and I can get all of them. Hello world, hello Greach, and this is awesome. So now the producer, and it's talking with Rabbit, but I haven't worried about how to configure everything. Because remember, I'm the new guy on the team, so I don't know too much about this application. But if I can have the application running in just 5 minutes, I can start playing with the application to see how it works. So now what I'm going to do is start the consumer. So let me split the screen. So again, it takes 5-7 seconds because I don't have internet connection or Ethernet connection. So this is the same, work, consumer, sorry, and Gradle W, boot run. And what is going to happen is that the consumer is going to start, and as we have 3 messages on the queue, the consumer is going to get every one of these messages. We are going to see here the log, and then we are going to see what happened on the database. So as you can see here, the default database connection is create drop, so the table doesn't exist, and Hibernate is creating the database for us. And here you can see receive message, hello world, hello Greach, this is awesome. And this is because of this one. So this is the service that is running on the consumer. You can see here. So everything is working. I'm going to create a new session, and I'm going to connect to the database to see what happened with the messages. Come on. So you can see here we have my database reverse up, so I can connect to my database, and you can see it only has one table, message. So select start from message, and here we have the 3 messages reversed: hello world, hello Greach, and this is awesome. So everything is working without worry too much about how to configure everything. The new team member, it's happy because it has the environment up and running. And this environment, it's for development, or it's only useful for development, and for one reason. So you don't need to worry about how you develop your application. So some of you probably use Beam, use Emacs, whatever you want. I don't. I use IntelliJ, and I can still use IntelliJ because the file system is shared. So what I'm going to do now, this is the producer, okay, the upper top. So I'm going just to change anything. Remember, it started in development mode, so I can do here to uppercase. I'm going to save the file, and what happened is that the reloading agent pick the change, recompile everything, just as it will do on your local laptop. So now I can send another message. This is really awesome. New message. So here, you can see now the message is in uppercase. And if you go, to the database, you can see that it's in uppercase and it's reverse. So as you have seen, you can start developing your application just as you do with your standard tools. You don't need to switch to Vim if you don't want. And you can use your local IntelliJ, your local IDE, your local browser, and only create the things that you really need to or for development inside the container. And the last thing I want to show you now is that, as I said, I'm also sharing the SDK man, the downloaded files, and SDK it's installed here. So I can, for example, open the Groovy console, everything. So let me do this. SDK list Groovy, or offline mode, probably. So yeah, but as you can see, I have these versions. I'm using this one. I'm going to open a new tab. So this is my machine, okay? Iván, this is my local machine. And, well, no, don't worry. So what I can do here, it's Groovy console. I can start the Groovy console inside the container. And here we have the Groovy console. And this is working because of this last trick we did here. I'm sharing the local socket. This is for Linux. I don't know how to do that with Mac and with Windows. I mean, up until now, or until 1 week ago, you need to install boot to Docker or Docker machine or something like that for Windows and Mac that basically will download a virtual machine image and run Docker inside that Linux image. I think now they have a beta version to run natively Docker on Mac and Windows. I cannot test it, so maybe this trick or something like that will work. So probably you need to Google a little bit about that. So this is running, and it's just the standard Groovy console. And as I said, so this is working, and what I'm going to do is I'm going to exit this tmax, so detach it. Now I'm on my local machine. Everything is shut down. Nothing is running, so if I reload, I don't have anything running. So it's pretty convenient. So this was the first demo. So one image to rule them all. And now I'm going to show you the other, which is, let me close this. Sorry. So we are going to use now Docker Compose to orchestrate and define how all those containers talk each other. So let's go here, Docker. Here we have the builder. This is more complicated because now we are going to use this to create the final artifact. So in the first example, we are running on development mode, but now we are running on production mode. So as I don't have anything installed on my machine, I need to be able to create a container with all the dependencies that I need to build the final artifact, so the final jar, and create an image with this artifact. So I'm going to do something like a Dockerception. So I'm going to create a container that will create another container inside of this. So the script is pretty much the same as the previous one, just run, and the name of this new image is builder. And the Docker file, it's pretty much the same, but now I only need the dependencies to build my application. So for example, I don't need now RabbitMQ, neither Postgres, because I don't need these dependencies to build my applications. So this is the same, local, but now I need Docker, because I'm going to build Docker images from another Docker. So let's run this. So again, it's fast because everything is cache. And here, here I have this builder image. No, let me show you here. I think it will be better. So it's pretty much the same as the previous one. Docker run, the builder image, my local directory, the shared volumes for Groovy, Gradle, and so on. And here I'm defining this entry point. This entry point, it's the script that this image or this container it's going to execute when it's called or when it is run. And the final trick is this one. It's the same as with the X11 socket. So I'm sharing my local Docker socket with the container. So all the commands, all the Docker commands that I run inside the container are actually going to be executed on my machine. And this entry point here, this is the basic help. So let's run it. Builder. So usage. What do you want to build? Postgres, Rabbit, the producer, the consumer, all of them. So let's build all of them. So Postgres and Rabbit, it's fast because all the image, it's cache. But now, as you can see here, I'm building the producer, and it's for production. If you have used Grails 3, you know that this is compiling all the resources, and it's creating the final jar. Now it's creating a container with that producer jar, again from Java 8, and the same with the consumer. So let me show you the script. So this is our entry point. I can build only one thing, or I can build all of them. And it's pretty much the same. With Postgres and Rabbit, I just create a container with this information. So for example, here we have the Postgres Docker file, which is pretty simple. I'm using Postgres. This is the directory, and this is my setup to create the initial database. It will be the same with Rabbit. And for the Grails applications, I execute Gradle, clean build, and prepare Docker. This is a very simple task. Let me show you again the build.gradle. Hello. Oh, it's freeze. Oh. Okay. I can know. Oh, now it's working. Thank you. So this is the task, the prepare Docker task, which basically depends on build, and it will copy the Docker file to build this image and on the jar inside this temporal directory, just to create the image. And once I have everything in place, I create the different images. So I can say Docker images, and you can see here, Rabbit, Postgres and Rabbit were built 6 days ago, but producer and consumer just a minute ago. So now I have these two images. So I'm going to start all those images using Docker Compose. So to use Docker Compose, you need to define this Docker Compose file, which is a YAML. It's pretty simple. So basically you define here, this is the name of my service. It's called Postgres, and this is the image. This is Rabbit. And for example, for a Grails application, the producer will use this image. I want to map the port because I want to be able to connect to that application. And I also need RabbitMQ. So this will create a link between both containers. And with the consumer, it's the same. I don't want to map any port. But for the consumer, I need RabbitMQ, and I also need the Postgres container. So now, Docker Compose. So the file is here, and I can run Docker Compose app. So it's going to create the 4 containers, and we can see here the log. Postgres is starting. It's creating everything from scratch. So for example, here is our database. RabbitMQ, it's starting. And now you can see any log, but both the producer and the consumer are starting, and we will see the log in just some seconds. Okay, producer up and running. And consumer, it's creating the tables. Here we have some Postgres log messages. And I think that's all. So now I can execute probably this again. Message send. As I have a map here, remember, I'm only exposing the local, the 8080 port, so no admin port for RabbitMQ. I cannot connect. I can reload the page, but it's not working because the port is not mapped. And here, so you can see the message received. This is awesome. It's in uppercase because I didn't change the code. So I have built the image with that modification. And I can also, I can check here, Docker compose PS. I have 4 containers running with every command. They are all up, and these are the ports. So the only port that I can use from my local machine is this one. And I need to be able to connect to the database to see how it goes. So I can, for example, do, let me do from here, Docker exec. I want to exec a command, which is going to be interactive inside some container. Which one? The Postgres one. And the command I want to execute is bash. So now I have a shell inside that container, and I can do exactly the same. I can connect to the database. I can switch to reverse app. The database or the table is here, and select start from message. And here we have the 2 messages. So the result, it's the same, but now the application is running on production mode. Remember, here you can see production and production, because I built the artifacts, and I'm starting the application with Java -jar and the name of the jar. So this is the other approach, one for development and one for pre-production, CI, or even production if you want. So this was my demo. Let me finish this very, very quick. So this was the demo. And just a final summary. So with Docker and Grails, it's easy to start being productive because you don't need to worry about knowing everything about the project. You are the new guy. You don't know about anything. But you can use it in just running a script, and you are done. The developers, all the development team has now the exact same environment, and we can control exactly the version of everything. So if we want to switch to Postgres 9.5 tomorrow, we are going to do because we want, not because my buddy is updating the distribution and it's running and it's broken and everything it's falling. But on the other side, the orchestration is more complicated. This example was pretty simple. But if you create more complex application with different components, this Docker file can be really huge. But on the other hand, it's more powerful because you can use it for production. You can use this Docker Compose approach for development if you want, but for my point of view, you don't have any advantages. You have the worst part, which is it's more complicated, and you don't have anything else because you need to change more images if you, for example, add a new dependency. So my advice or my approach is 1 image for development, more than 1 for production. And at the end, everyone is happy because I'm the new guy on the team, and I feel productive from the very beginning, and I don't need to worry or to annoy my company, my colleagues, my new colleagues. So can you help me, please, how I need to configure, or how I can configure Postgres, on how I install Rabbit, what do I need? So that's all. Thank you very much. This is my contact information. Here you have in this QR code and this URL, this is an anonymous Google form to send me some feedback about the talk. So it will only take 30 seconds to fill this. So if you like the talk, please say to me. And if you don't like, please say to me. It's anonymous. You can say whatever you want. It was crap. I don't care, but send me some feedback. And I think, well, I'm being a little bit late. So if you have some questions, maybe 1 or 2, but no more. Yeah?
It's still possible to debug the application?
The question is it still possible to debug the application? Yes. You only need to map the port in which the Java agent it's 50005, and you can map it and you can connect from IntelliJ. Yeah. Yes.
Suggestion: you can add that several production sites share the same Docker file.
So sorry, what?
A suggestion.
Yes. Suggestion.
You explain that the Docker file for developer
Yes.
are the same for production.
No, they are not exactly the same.
Okay. The message is the problem is when I have several production sites, this system is very efficient.
Okay, so thank you, yeah. Because everything is the same, you don't need to worry about, yeah.
You can control.
It's more, yeah, because at the end this Docker file it's on your Git, so you can control exactly what you want. Okay, so I don't have more questions. So if you want to talk to me, no, after. Sorry, I'm running late. So thank you very much. Enjoy the rest of the conference.